Bismillahirrahmanirrahim. Assalamu alaikum. In this session, we will talk about integration by parts and then reduction formula of sine power n. So let's first talk about integration by parts, right? So I will start with the product rule of differentiation, in other words, Leibniz rule. So I know that if I have got two functions, let's say u and v, which are depending on x, and I want to differentiate these two functions with respect to x, then my Leibniz rule for this case says that you differentiate your u and you keep your v same, and then plus you keep your u same and you differentiate your v of x. Or simply I can write the derivative of uv is same as derivative of u v same plus u same derivative of v. From here I can do what? I can use integration by parts, or so sorry to say integration by parts, separation of variables can be used, and I can write, not even say separation of variables, but let's integrate with respect to x on both sides. So I can write this way, plus u times dv over dx, which can be simply written as, so roughly this will cancel with this and this will cancel with this, so I can write the derivative of uv, or integral of differential of uv is same as v du plus u dv, or you can write from here, because it's the differential and integral together, so uv to be equal to v du plus integral of u dv. So from here what I can say is basically this following: u dv is equal to uv minus integral of v du. So that's the integration. So now we will use this integration by parts to find the reduction formula for sine power n of x dx, where n is of course greater than equal to 2. So what we will do now, we will break down the sine power n into two functions. One is sine power n minus 1 of x, and the other one is sine x dx. So I will treat this as u and I will treat this as my dv. So my u is equal to sine power n minus 1 of x, and my of course dv is equal to sine x dx, right? So from here if I differentiate, then my du should look like n minus 1 times sine power n minus 2 of x into cos of x, and v should be, on integrating both sides, my v should be equal to minus cos x, right? So now I will use the formula, and my formula says that your u dv should be equal to uv minus integral v du. So this implies that u, which is basically sine power n minus 1 of x, and v, which is dv, which is sine x dx, it should be equal to u times v. So my u is sine power n minus 1 and cos, the v is cos, so this is going to be minus times sine power n minus 1 of x into cos x minus this formula, and my v is of course minus cos x, so minus can be multiplied, okay, so I will write minus cos x, and my du is equal to n minus 1 times sine power n minus 1 n minus 2 of x times cos x dx, right? So then, so this is my integral I, so my integral I should be equal to minus sine power n minus 1 of x cos x minus into minus this plus and n minus 1 over here. Then I have sine power n minus 2 times of x times cos square of x dx. So my integral should look like minus times sine power n minus 1 of x cos x plus n minus 1. Now if you multiply this, so first you will break your sine n minus 2 of x. First you will break your this cos square into sine, which is 1 minus sine square x, right, dx. So that what will you get from here is this minus sine power n minus 1 of x cos x plus n minus 1 times the integral of sine power n minus 2 of x minus, so it is going to be equal to sine power n of x dx, right? Okay, so this is my integral I. So my integral I should be equal to minus sine power n minus 1 of x cos x plus n minus 1 times of this sine power n minus 2 of x dx, and then you will multiply your this n minus 1 over here times sine power n of x dx. But recall this sine power n, the integral of sine power n is equal to I. So my I should be equal to minus sine power n minus 1 of x cos x plus n minus 1 times integral of sine power n minus 2 of x dx minus n minus 1 times the integral I. But I can take this term on the left side, so I will have this one I plus n minus 1 times I to be equal to minus sine power n minus 1 of x cos x plus n minus 1 times the integral of sine power n minus 2 of x dx. But then you can simplify this side. You will have I plus ni minus I to be equal to minus sine power n minus 1 of x cos x plus n minus 1 times the integral of sine power n minus 2 of x dx. But this I gets cancelled with this I, and what you will be left with is the form integral equal to minus sine power n minus 1 of x times cos x, all of this divided by n, and then plus n minus 1 divided by n times the integral of sine power n minus 2 of x dx. Now let's apply this. So like my integral was equal to what? So my integral was equal to sine power n of x dx, right? It is equal to minus sine power n minus 1 of x cos x divided by n plus n minus 1 divided by n times sine power n minus 2 of x dx, right? So now I can apply this formula on a particular n. Let's say we will apply now it to sine power 3. Let's compute sine power 3 of x dx. So this should be equal to minus sine power, so 3 minus 1 is 2 x cos x divided by n, which is 3, plus 3 minus 1, which is 2 over 3 times sine power integral of sine power 3 minus 2, which is basically 1. So this is just sine x, then which you can simplify further, sine square of x cos x divided by 3 plus 2 over 3, and the integral of sine is minus cos x plus constant c, so minus sine square x cos x divided by 3 minus 2 over 3 cos x plus c. So this is how you can apply. So now if you will apply it onto 4, then here you will have sine power 2, and again you will repeat the formula. So like you can apply it uh, successively to get the integral of sine power n. I will try to apply it for the first. Apply it for n equal to 4 sine power 4x dx. So you will apply the formula minus sine power, it was n minus 1, so it is going to be 3x cos x divided by 4. Then we have plus n minus 1, which is basically 4 minus 1 divided by n, which is 4. Then integral of sine power n minus 2, you mean 4 minus 2 of x dx, right? So this is going to be equal to minus sine power 3x cos x divided by 4 plus 3 over 4, and then we have sine square of x dx. But here you can repeat your formula again. So it is going to be minus sine power 3 of x cos x divided by 4 plus 3 over 4. If you have forgotten the formula, then you know you can write on your page by backing this video. So the integral of sine squared, uh, so like you can apply now for n equal to 2. So when you will apply it for n equal to 2, it is going to be equal to minus 1 over 2, then sine power 2 minus 1 is 1, then we have cos x and plus 2 minus 1 over 2, and then integral of sine power 2 minus 2, which is going to be basically 0. So this is how you will solve. Minus sine power 3x cos x divided by 4 minus 3 over 8 times sine x cos x, and then this is going to be 1 over 2. So when you multiply it by 3 by 4, it is going to be plus 3 over 8, and this is 1. So integral of 1 is x plus c, right? Thank you.